what it is. Maybe half. Vogtlin? Vogtlin?
It's not Vogtlin.
What's your name?
Okay, so like I said, there's several different ways
Spelled the same way.
to measure pH, and it depends on if it's an acid or base. Some of you did the litmus paper, the red and blue litmus paper, and it changed colors if it was an acid or base. Those ones are just narrow spectrum ones, so one is made for acids, and one is made to measure bases. What I made today was using red cabbage. Some of you may have done this in elementary school, where you boil red cabbage and you can actually use it as a pH indicator, and it's a full spectrum one. And it depends on what color it changes to as to what pH it is. So inside of here I have some nasty smelling red cabbage juice. What it normally looks like, I should show you so you can see.
Do we have to smell it?
No, you don't want to smell it. My whole house smells all high. It normally looks like this color. So that would be the normal pH, because this is the pH of water. So it would be around 7.
So that's the cabbage juice?
Yep, so that's what it looks like. So you know that purple cabbage that you get at the store? You can just boil it in water and then it turns the water that color. And then you can use it as a pH indicator. So I have some everyday objects up here. The first one I have is hot sauce. So just a couple drops of hot sauce. And when you add it to it, it changes it a bright pink color. So it went from that blue to pink. So the pink colors are going to be acids. So actually when you're using hot sauce in your food, it's actually an acid. And I have, I believe this one's vinegar. I'm not going to spell it, but I'm just going to trust myself. Yep. Vinegar is also known as acetic acid. So it's also an acid because it turns pink. Hot pink, yes. And then I have just regular soap, dish soap. And when you pour it in, it's a little bit more blue, so this is actually more closer to 7 than what you see that's in the container over there. Oh, it stinks. And this one is bleach, so household bleach, if you have cleaners in your house. And it turns it to more of like a greenish blue, so that means that it's lower on the pH scale than water. And then our last one is baking soda. I'll swirl it around a little bit. And this one is even a little bit more basic, similar in color, but it's just because it hasn't gone into solution yet. It's even more basic than the last one. So you could actually make this at home yourself, but you smell it. It smells really awful. My whole house stinks from it. Last year I did a lab involving it, but we all boiled cabbage, and by the end of the day everyone was like, what is that awful smell? So I decided not to do it this time. So is that kind of a reminder of your acids and base that you've learned in the past? 0 to 7 were your bases.
I remember how fun it was.
What?
I remember how fun it was.
You remember how fun it was? Okay, so I put some examples on here, just like you've seen in the past. Vinegar is commonly called acetic acid because it is an acid. Lemon juice, so if you have also orange juice, is a little bit acidic as well. That's why sometimes it gives you heartburn. Tea is actually also acidic. It's slightly acidic, not like hydrochloric acid acidic. And if you've ever stepped on an anthill, yeah, those red ants that crawl on you and it burns, that's actually formic acid that's going onto your foot. So when they bite you, they release that formic acid, and that's why it burns so much when they bite you.
And
what?
does it hurt you?
Yeah, you've never stepped on red ant hill?
Oh my
I didn't know about them when I first got here, and I was just walking in my backyard, and I stepped in one day, and I looked down, and they were all over me.
Well, like I
And
know
I'm
they
well
burn.
done.
Like I know they burn and stuff. I just
Yeah.
didn't know like the formic acid like.
So an acid, when it reacts with water, produces hydronium ions, which is the H+ ion. And there's some properties of acids. Obviously, if I said, hey, here's some hydrochloric acid, you wouldn't actually taste it. But if you think of lemons, if you bite into a lemon or lime, it's got that sour taste to it. That's because it's an acid. And it's also corrosive, so anything like hydrochloric acid. They actually use what's called hydrofluoric acid to etch glass. So So they actually release it into certain parts of a piece of glass and etches that glass and eats away at it. It turns litmus paper red, so if you have it, that's off a little bit. It reacts with metals to form hydrogen gas, so if you have, for instance, hydrochloric acid and you put a metal into it, you can actually see bubbles forming around that metal, and that's that hydrogen gas that's being released. Aqueous solutions of acids are electrolytes, so they must be mixed with water. And it reacts with bases to form water and salts. So if you have an acid and you put a base into it, it'll actually form water and salt. So if you have hydrochloric acid, you put sodium hydroxide in there, it actually in the end is just salt water. Technically you could drink it at that point, but I strongly suggest against that, obvious reasons. Some other examples, if you have ever had, which I'm sure most of you have, Sour Patch Kids also has tartaric acid and citric acid in it, so next time you look at those. And that's why after you have a few of them, your tongue burns.
Yeah.
Yeah, so that's from those two things. Alright, bases. Compounds that produce OH ions when they are in water, so they're called hydroxide ions. And then examples, milk of magnesia is kind of a little bit before your time. Neutralizes stomach acid, but you can actually buy that at the store. Another one would be Pepsid is another example. It's got a base in it and it just settles your stomach a little bit. Also, for those of you who have ever done cleanups of your drain, if you use Drano, it's a very, very, very strong base. That's why they say do not get it on your skin. If you do, wash it off immediately. They also suggest wearing safety goggles when you use it. The more common ones now are like a thicker liquid so it doesn't splash as much. But if you ever need to use Drano for any reason, obviously be very careful with it. Okay, properties of bases. Obviously you don't want to taste it, but if you were, it would have a very bitter taste. So an example would be if you took the baking soda, mixed it with water, and you drank it, it would have a really bitter taste to it. Slippery, if you think of some soaps that you've used, like a bar of soap, that slipperiness is actually because it's a little bit basic. It turns litmus paper blue, and in solutions, bases are electrolytes that must be melded with water. That was the same as an acid. It also reacts with acid to form water and salt, so just like the bases did. And on a pH scale, acidic is 0 to 7. Like I said, 7 is neutral. What you may also find is regular drinking water that we drink out of the faucet is not exactly neutral. A lot of them are closer to about 5. And then you have vinegar, lemon juice at the top. And ammonia is an example of base, and also baking soda is just slightly basic. All right, any questions on that? Okay, I'm going to stop recording for now.